Hello everyone and welcome to a new video. In this video, we will be introducing two new terms, potential energy and potential difference. So let's understand what potential energy and potential difference means. Let's start with this simple example. Now imagine if we added a positive charge between two parallel charge plates near the positive plate, okay? We added a positive charge. What do you think will happen to this charge? See, the charge is in yellow. What do you think will happen to this charge? Exactly, we all know that this charge will be attracted towards the negative plate, okay? Now, what caused this movement? What happened to this object? Why did it move? Well, it's obvious. It moved because it got attracted to the negative plate. Yes, exactly. It moved because we gave it something called potential energy. For any object to move, it needs energy. Where did this energy come from? Well, it came from the uniform electric field. So it's very easy and pretty obvious. So we can say that the potential energy is the energy that was given to this positive charge from the uniform electric field. Okay? The unit for potential energy, or actually the unit for all types of energy, is joules. So potential energy is just a different type of energy. We learned that we know that there's something called the kinetic energy. We know that there's something called the heat energy. So there are different types of energies, and one of them is the potential energy created between two uniform electrical plates. Now, the equation to calculate the potential energy that was given to this charge, it's very easy and straightforward. It's equal to Q multiplied by E multiplied by D. PE will stand for the potential energy and its unit is in joules. And we know that the unit of the charge is Coulomb, and the strength of the electrical field, we will call it E, and we learned that from the previous lesson. And finally, D is the displacement of the charged particle. In other words, how much did this particle move in this field? So actually the distance between the plates plays a huge role in the potential energy. Now try dividing the potential energy by the charge. So if we have the potential energy and divide it by the charge, we will have something called the potential difference, which is the other term we said that we will be introducing. Potential energy and potential difference. We understood what potential energy is. It was the energy given to the charge when it was between two parallel plates in a uniform electrical field. But what is a potential difference? Well, actually, by numbers or by equations, it's just simply if we divide the potential energy by the charge, we get something called the potential difference. But let's try to understand it physically more. First of all, we must memorize that the unit of potential energy is volt. Okay, now let's imagine it this way. We know that if we have 6 million electrons, we will have something called 1 Coulomb, right? If I give this 1 Coulomb 1 joule of energy, 1 joule of potential energy, we will get something called the potential difference, or we will get something called 1 volt. So if I give 1 Coulomb of charge a unit of energy equal to 1 joule, I will have something called 1 volt, which is the potential difference. Okay, now what's the equation to calculate the potential difference? It's actually, as we said, if we divide the potential energy by the charge, we will get the potential difference. Okay, so simply we can say that the potential difference, we will be using the delta V for potential difference. Okay, we know that the potential energy is equal to the charge multiplied by E multiplied by D, right? So if we divide the potential energy by the charge, we will get rid of the charge here. So we know that the potential difference will be equal to E multiplied by D. So now we can find another equation to find the potential energy. It's simply, we can say that the potential energy is equal to the charge multiplied by the potential difference. So it's the charge multiplied by the potential difference. Just to memorize everything, we know that PE is the potential energy, the unit is joule, delta V is the potential difference, the unit is volt, and finally Q is the charge of the particle, and it has the unit of coulombs. Now, the potential energy can have a positive sign or it can have a negative sign. When does it have a positive sign and when does it have a negative sign? Actually, it's pretty easy. If the positive charge is going towards a negative plate. So let's say we have two plates. we have a positive plate and we have a negative plate. We know that if we add a positive charge and if it was moving towards the negative plate like it's supposed to, we always know that positive charges go towards the negative charges. So if it's moving like it's supposed to, that means it will have a negative sign. The potential energy will have a negative sign. That also goes correct for negative charges. If we have a negative charge right here between two plates, this is the positive plate and this is the negative plate, and we add a negative charge, we know that the negative charge is going towards the positive plate. In this case, it will also have a negative charge. So there are two cases. Actually, just memorize it. If it goes as it's supposed to, that means it will have a negative sign. That means if a positive charge is going to the negative plate, it's supposed to do that. So it will have a negative sign. The potential energy will have a negative sign. And if a negative charge is going toward the positive plate like it's supposed to, that means it will also, the potential energy will also have a negative sign. But if the charge was forced to move opposite to the way it's supposed to, in other words, if I had to push the positive charge towards the negative plate, if I had to push the positive charge towards a positive plate, we know that positive charges will repel. But if I'm forcing it to move towards the positive plate, that means it will have the potential energy will have a positive sign. And that also goes for the negative charges. If I'm pushing a negative charge towards a negative plate, the potential energy for this charge will be a positive sign. So actually, it's pretty simple. If it's going like it's supposed to, that means the potential energy will have a negative sign. But if we're forcing the charge to move, remember, if we're forcing the charge to move, we are giving it energy. We need to push it. That means that the potential energy will have a positive sign. Okay? That's all what we have to say about potential energy and potential difference. Two new terms. They're not complicated at all. They're very easy. Watch this video again and again until you get the idea. And stay tuned for the next video. We will be solving problems on potential energy and potential difference.